Okay, so this in this demonstration we are using heat blocks. Fantastic, you're getting some of these. So let me tell you how I use this in my classroom. The first thing I do is I give each group a set of the 2 blocks. And this is an important step. They have to have time to observe the blocks. They need to feel it, they need to, and I do have to tell them, just don't drop them, but you can pick them up, or you can just touch them laying on the surface. You can touch them, not a problem. But in their notebook, and I really wish I could show you one of my student notebooks, I have them draw 2 squares, just like the blocks. And on their table, I would have a sticky note labeling, this is block 1, this is block 2. So I'm going to have them observe. Inside the box that they've drawn in their notebook, I have them make observations, because this is an important step. One of the first things you're going to notice, of course, they're both black, but they're going to notice, well, this one's dull and this one's shiny. And if they touch them, this one feels cold and this one not so much. If they pick them up, this one is heavier, this one is lighter. So there's a few things that they could write down inside each block. We discuss their observations, and then I ask them to make a prediction. So, and I know again, you can't see this, but when you get this presentation, you will be able to see it. And in their notebook, I have them write. I show them ice cubes, and I say, okay, which one of these blocks do you think we could put an ice cube on and it not melt? What would I do? Yes. Which one of these blocks would keep an ice cube from melting better? So, another key piece, you definitely want these little bands. You're going to put these little bands on here. Once you get to the piece with the ice, it happens so fast. So what I do, I distribute the ice to the tables, and I do not let them put the ice on the blocks until I say the magic word, because, well, you'll see why in just a second. So I tell them, I have 2 people from each group, each one gets an ice cube, and they're going to put them on the blocks at the same time. So they've already made their observations, they've made their claim, they've given their evidence. Now we're going to see what happens. So we're going to place an ice cube on each block. Can they see this? So I'm hoping that you are able to see this, because the block that the majority of students are going to say would keep the ice cube from melting because it's cold to the touch, look what has happened to the ice cube. It's almost completely gone. It's all water as I pour it off onto the table here. While this one, the ice cube is still intact. So you have to be quick when you're doing this, because as soon as that ice cube touches this block, it begins to melt. Why? Where does the heat go? Heat always moves from warm to cold, right? Did I say that right? Did I say that right? Sorry, I'm old. I have to question myself from time to time. Yes, heat always moves from warm to cold. So what's happening here is the heat is actually being conducted away, and the ice is melting. So even though the block feels colder, it feels colder because it's conducting the heat away. And I just made a mess. But these are your heat conductor blocks.